equations, which are basically the fundamentals, or not the fundamentals, but the most basic or the simplest kinds of differential equations to solve. Okay, so what is a separable equation? So it's kind of not self-explanatory, but it kind of the title of the terminology, like separable, that kind of gives it away as to what the equation does. So a separable equation is an equation in which, I'll write out the definition for you, in which the variables can be easily separated, okay? Can be easily separated. And by this, mathematically, what I mean is that let's say we have a dy dt, which is the first derivative, right, of our y of t function, our single variable function here, or this is also known as y prime, right? So you can see it written either way, so you can be familiar with that. And then, so basically we have something that looks like this, where we have a function of t and times a function of y, or something like that, okay? Or I'll write a big or here, we could have something like this, dy dt, or you might see this y prime. I'm just writing both here so you'd be familiar with both. Or we could have like g of t over an h of y, some function of y. Right now it doesn't really make a whole lot of sense with the variables and everything, but you'll see once we get into examples how to recognize whether an equation is separable right off the bat or not, okay? Or we could have, the last option would be like h of y over g of t or something like that, okay? So basically we have, what's going on here is we have two functions, each of their own variable, their own like different variable, two functions being either multiplied here, so this is the multiplication, here's division, and here's division 1 there, okay? So basically what you can do in each of these is separate those variables. Okay, so these are the, like I said, separable equations are relatively easy compared to all of the other kinds of differential equations we'll learn how to solve later on in the course. Okay, so let me show you an example on how to tackle one of these problems. So once we have something like this, I'll just write up one of these. So dt, something like this. This could be equal to, let's say, g of t, some function of t over some function of y, okay? So here is what we're going to do. So how to solve separable equations. And it's pretty simple. So three big steps. Alrighty, so here we go. So the first thing is going to be to separate your variables. Separate your variables. And by separate, we mean put, like, kind of sort them so that we have all of one variable on one side and all of the other variable on the other side. So in this case, what we would do for this guy is move all of the y stuff to the left side, okay? So we're going to multiply by h of y on both sides, multiply by h of y, and then we want to get all the t's to the right side, okay? So then we'd have to multiply by this dt down here to get rid of that. So times dt on both sides, and then times dt on both sides, right? So now we have the dt's canceling out and the h of y's, those functions there. So we get something that looks like h of y dy is equal to g of t dt, okay? And like I said, this will be a little bit more explicit when we solve with actual functions and we're given like numbers and things like that. Okay, so here we separated the variables, right? We have all the y stuff on the left. Here's the equal sign separating them, and then all of the t stuff on the right. Okay, so we separated our variables. That's step 1. The next step would be to integrate. Okay, so that's pretty straightforward. You just integrate both sides, okay? And then that's good because we already have our differentials here. Differentials meaning d something, d whatever variable you're dealing with. So we already have that, so we're good. We just integrate straight through. And then at the end, we're just going to get our, I'll just call it y of t for now, or our y, or just like our y, whatever our function is, the name of our single variable function, get this by itself, okay? Alrighty, so just keep these 3 steps in mind, and I'll start on an example. Okay, so here's a basic example, and it's just called basic because we'll see it pop up every, pretty much every section. or if not, maybe every other section or so. So we're going to start with something like this. Y prime is equal to negative lambda, that's the letter there, times y, okay? And lambda is a constant, kind of like a number. Alrighty? Is a constant. Okay, so here, what I always like to do, as for separable equations or for anything, usually for separable equations, is whenever I see a y prime or something like that, I'll turn this guy into a dy over, and we can make our variable dt, okay? Because there's no other t, this again, this lambda here, that's not a variable, it's just a constant, so we can consider that like a, b, c, whatever. So anyways, so we don't see any other independent variables, so we can just say that everything depends on t, let's say, okay? So this is dy dt, and then on the right side we have negative lambda times y. And then this is a y of t, but let's not write that t in there so we don't confuse ourselves, okay? So now what we're going to do is separate, right? That's the first step. Well, the first step here, kind of like the 0th step, was just rewriting this y prime as dy over dt. Okay, and now we're going to separate, so I'm going to bring all the y stuff to the left side, so that means we're going to divide by y on both sides, divide by y, and at the same time we can multiply by this dt to get it to the right side. Multiply by dt. Okay, so we see how the y's cancel on the right, and the dt's cancel on the left, and we are left with 1 over y dy on the left side, and then on the right side we have this negative lambda times dt. Okay, so that was the second step. That was the first step. We have just separated our variables with this equal sign here, across the equal sign. Okay, now the second step is to integrate on both sides. So we just simply write an integral sign and we integrate. So then we get ln of absolute value of y, the absolute value is important there, is equal to, and then when we integrate this whole thing is just a constant. So we're just going to write negative lambda times t. And we can't forget our plus c, remember, because we have an indefinite integral here. There are no bounds to it, so we have to have that plus c in there. Okay, so here we just integrated, and we aren't done just yet because we still have step 3 to go, which will continue on the next slide. So we're left at ln of absolute value of y is equal to negative lambda times t plus c. Okay, so now our job is just to get this y by itself, okay? And sometimes it's easier said than done, right? So, but first off, we can start with maybe big exponentiating both sides, right? So write a big E, right? And then these can cancel out, so that'll be nice. And then we're left with the absolute value of y is equal to e to the negative lambda t plus c. And we can use the laws of exponents, right? Because when exponents are being added, that basically means that we're multiplying the product of, well, we're multiplying the two quantities here, so e to the negative lambda t times e to the c, right? Okay, and then the last thing is to get rid of this absolute value sign. So we can have, to get rid of that, we just add a plus or minus on the right side, because it could be plus or minus, this whole quantity here. So e to the negative lambda t times e to the c. And this basically gives us our y of t, okay? So we have just isolated our y of t, or our y. And then we have something like this, which I'm going to rewrite in a little different form. So we have this plus or minus e to the c, and oftentimes, because this doesn't look very aesthetic to the eye, we can create any new constant. And usually I use like a capital A or something. So we're going to say a is equal to plus or minus e to the c. And it doesn't really matter because remember c was just a constant to begin with anyways. It's just an arbitrary constant that came from the indefinite integral. So now all we can do is just kind of like relabel this whole entire thing so we can just replace it with one variable. So ultimately we can get something that looks like y of t is equal to a, which is a constant, equal to this guy, times e to the negative lambda t. Okay? And that would be it. This is not our particular solution because we do still have a constant here, right? So this would be our general solution to the original ODE, or ordinary differential equation, that read y prime is equal to negative lambda times y. Okay? This was our original ODE here.